Well, Tony, I feel like I'm sitting here with a legend. Thanks for joining me.
Great to be here, Joe.
Yeah, so SRS, you've been at this for how many years training some of the world's best surgeons?
I've had 20 years of training fellows in robotic surgery because we started pretty early. We had number 5 Da Vinci in the world, 5th installation. So we started 2002, 3, and the rest is history. So I had a lot of experience in training, and I'm very proud. We've got a lot of fellows around the world who have reached great heights in proficiency in using the robot, having had a good experience in Melbourne, Australia.
And number 5, was that in Melbourne?
Yeah.
And so they flocked to that corner of the globe?
We did, yeah, because we actually had a training position which was very unusual in those days, because most surgeons were transitioning from open or lap to robotics. So after about a year, I thought I knew how to do it, but about 10 years later, I thought I knew how to do it, and then 20 years later, thought I was getting pretty good.
You said something earlier, we had a chance to chat, that sort of stopped me in my tracks. You said, usually surgeons teach surgeons, but when robotics started to get its traction, robotic companies were teaching surgeons.
Well, that had to be in a way, because the technology was way ahead of medicine, or the surgical application of it. So the engineers bring along this magnificent weapon and then put it in the hands of the surgeon. They originally gave it to cardiac surgery who couldn't use it in Detroit, and then the urologists decided they'd have a go at it. And a guy called Manny Menon, he worked out how to take the prostate out with a robot, but no one in the world knew how to do that. So the device manufacturer, Intuitive, had to sort of train the surgeons, whereas I think that's sort of analogous for Boeing giving a 737 to the pilot and saying, you go fly it, press these buttons. So eventually we, as surgeons, had to catch up to the technology, and I think we've done that now, and I think that we now have a way of teaching the technology to surgeons in their training.
We're at SRS here, and I think Vip said maybe 6 years ago there were 2 robots at SRS, and now I think there's north of maybe 40 here. What are the main milestones, no matter whether you're on a D5, on a Dexter, on an MMI, an SSI, what are the things that we've got to constantly stand guard at in the training curriculum in these platforms?
Well, I think hospitals are going to have multiple platforms, so surgeons are going to have choices of different platforms. And I go back to the aviation analogy. There are some pilots who cannot transition between Airbus and Boeing. They just cannot handle the avionics. And there are some surgeons who struggle to say, move from a Da Vinci to a Medtronic machine or to a Cambridge machine. So it's very important, I think, to have an in-service. So if you want to change from a Boeing to an Airbus, you're out of the air for 3 to 6 months. And I think we should be very aware that these technology changes could provide some hazard to the patient if the surgeon isn't proficient in changing platforms.
Early days, I have to imagine you learned surgical robotics on the patient.
We did. Well, that was the Halstead method. That was training of a surgeon, 1904, Johns Hopkins Bulletin, and I trained in Texas under that lash.
Not 1904 though.
1904, well, no,
Not you.
I'm a little younger, but I trained in the 1980s in Texas, but we trained on patients. And that was the way we had to train. There was no alternative. These days, I think we can do a lot better, and we shouldn't be making our mistakes on the patient. We should make them in the simulation lab, and do repetitive training on simulation to proficiency, and then go under supervision into the operating room.
And therein lies the genesis of IMRA.
IMRA, that's right. So we started in Melbourne in 2019. It's the International Medical Robotics Academy, and originally I thought it would just be for our local consumption in Australia to train Australian surgeons, but the idea has caught on, and now we're actually internationalised into a lot of countries, Ireland, England, Germany, New Zealand, Australia of course. We're making some inroads here in the United States, possibly Canada. So we've internationalised a curriculum working with the credentialing bodies, so the Royal Colleges, College of Surgeons of Ireland. We're talking to the Royal College of Surgeons of England, Australia, New Zealand, etc. So, and we've met with the American College of Surgeons to talk to them about curriculum change and curriculum design. But what we really need to do is take a training program starting with a resident, first year, basic robotics. In fact, what we've done at IMRA, we've gone back to med school because about 30% of medical students want to do surgery. So it makes sense to have a semester of robotics in med school. In fact, in Melbourne University Med School, we have that semester, and it's support for that's overwhelming from the students. And the University Med School has now got a combined medicine engineering degree. So you're doing medicine and engineering at the same time and come out with a double degree, because we're getting bombarded with AI, with this robotic technology. How are we going to use it? You know, the companies keep coming up with innovation that we need to be able to use.
Yeah, and you bring up a really interesting point. And I want to go back to the pilot analogies and the aviation analogies that digital surgery and surgical robotics continue to refer to. So if you want to be a good pilot, you can memorize things. If you want to be a great pilot, you understand and are required to understand the physics of why lift occurs on an airfoil. And then from there, you can troubleshoot or make well thought out decisions based on the knowledge of physics, not on what an aileron does, or why. You have to understand why it does it, because that's going to save your life.
Yes.
And it almost feels like that's another analogous sort of point in digital surgery, is you need to understand the physics and why things are happening on that robot and troubleshoot, because you are going to hit, right?
There's no algorithm that's going to get rid of the surgeon. You still need somebody in charge. And we don't have driverless cars yet, and we don't have pilotless aeroplanes, and I think it's going to be a long time we have surgeryless surgeonless surgery, because no matter how many algorithms you make, there's always some point of difference in the decision making. I think there will be parts of the surgery which will become autonomous, driven by algorithms. Say putting ports in, for instance, that could easily be done now, I think, with AI. But beyond that, a lot of the dissection will need to be done by decision-making surgeons.
Yeah, and I don't even know if we'll have it autonomous. I think we'll get high level of advisement and confirmation from the surgeon, right? Yeah, I think
to make it safer.
Yeah, just to make it safer, and for a liability perspective, of course, right? Because the FDA, I don't know if Jeff Shuren and the team there is going to let that happen, that we have an autonomous robot. So coming back to IMRA, beside a training curriculum, we've also got pretty substantial models you've been developing as well, right? Could you share some of that?
Yeah, so some years ago I was visiting Indy Gill down in University of Southern California, and he had a couple of young residents in the lab, and one of them, Ahmed Ghazi, was making these synthetic human organ models, and the light bulb went on, because it became obvious to me quite a long time ago that using cadavers and live animals was not the way of the future to train surgeons. One, they're single training events. They're bad models because mostly it's pigs or dogs, and one, they're animal rights. I think that's going to put live animal surgery out of business anyway. Yeah. But they're not the same anatomy. So what we're doing at IMRA is making a very high fidelity synthetic human organ model, which we put into a torso, which is very similar to the human torso. We can make a dad bod, big guy. We can make Arnold Schwarzenegger. But we make them with transurethral, transvaginal, transanal orifices with cartridges we plug in. We insufflate the torso, and then we put a kidney in with a kidney tumour that we've made from 3D printing, and then we can give that a blood supply, and then we can simulate a partial nephrectomy or a nephrectomy or a prostatectomy, and get all the steps of that operation done over and over to proficiency. And then you say to the student, you're ready now to go to the operating room under supervision. And what pilots do, the first time they take a plane from Melbourne to Sydney, that's the first time they've actually flown the plane.
Yeah.
Because they've been in the simulator the whole time and they've done all their training in the simulator.
That's
so
right.
they're good to go. And I think that analogy, the aviation analogy is a very good one. Simulation brought the accident rate when it was introduced in the 1980s to minuscule in the air industry. We have an accident rate in surgery which is embarrassingly high, and I think a part of that is not good. The training's not good enough.
I also think it becomes an unlock for the sales of additional systems coming out, right? Because I was at LSI a few months ago, and Intuitive Foundation put a great presentation on, and the woman who put it on said, it takes 10 years to make a surgeon, it takes 1 year to build a hospital. And it was pretty, graphic of a visual. And so not even a competent surgeon perhaps, or an excellent surgeon, because how many reps can you get on a $3 million robot when it should be out making money?
Yeah. Good point, Joe. The other thing about surgical competence, what we found with our simulation exercises, we can actually test, well, firstly, hand-eye coordination was never tested when you went into surgery. Like, you just said, I want to be a surgeon. Nobody said, well, let's see what you like in a simulator. And it's like, I use the golf analogy. Some people cannot hit a stationary ball or hit a tennis ball. And there are 10% of medical students that don't have the visual spatial coordination to be able to be a surgeon. And that's a simple thing, but we should be, I think Mayo is using that simulation for their surgical selection. Mm-hmm. And there are majority of surgeons are adequate to good, and there are about 10% who are super surgeons. They're like pro golfers. So there's a wide variation in ability.
Yeah.
So that's going to become more apparent as we get more into the AI.
So as you wrap up, what has surprised you most in the first day and a half here at SRS 2024?
I think the profusion of platform technology. I just think I think you said it before we started. It used to be one or two robots. I can't keep up now. You wander around, and there are going to be niches for all these different platforms. For a lot of them, some of them won't fly, but most of them will have a role, depending on the way you're going to use them, and that blows me away. This medicine has changed so dramatically in the last 10 years.
Yeah, and let's hope it keeps on changing, because it's fascinating being an engineer and falling in love with this industry. It's fun to watch.
Well, the winner's going to be the patient.
That's right.
Okay, we got much gentler ways. When I started surgery at MD Anderson, when we took a bladder out or a prostate, the patient was in the hospital for 3 weeks. They would have a 5-litre blood transfusion. They would hobble out because we'd take a bit of their pubis out to get access to where we wanted to operate. They were always incontinent. We never talked about erections because we thought the nerves went through the prostate. So taking the prostate out meant end of the music. So from 3 weeks hospital stay and hepatitis, often from the blood transfusion, to a day surgery with no incision or tiny cuts, with a fair chance of mostly continent, or most of our patients are continent. This is radical prostatectomy, and now we're giving them a fair chance to start the music again.
I love it. Well, Tony, I appreciate your time and your insights on everything.
Great to talk to you, Joe.
Thank you, sir. I'm Joe Mullings from SRS 2024. Be well.